shot, is it sort of waist up?
Yeah, just like that.
Yeah, okay.
Okay, so this is Howard Walensky with Peter Doran, and we're talking about Antarctica and Chicago. What does Chicago have to do with Antarctica?
Chicago has very little to do with. Let me start again. Chicago is impacted. Is this a serious question?
I'm being facetious.
Yeah. Okay. So
I'm just trying to break the ice,
yeah,
if you will.
yeah. But you wanted me to start it with the robot, so so part of my research is related to the origins and evolution of life on this planet. And in order to answer those questions, you have to go to some places that are very primitive and very extreme. And so one of the place I do most of my work is in Antarctica, in these places called the dry valleys. And NASA is very interested, has been for a long time, in these regions because they want to see how life survives on the edge of these places where it's hard for them to survive. What are the strategies they use? And then these lessons we learn in these places will take us to other planets perhaps and give us some informed investigations there about where we might look on these other planets and what kind of fossils they might leave and stuff like that. So I work in these lakes that have often been described as good analogs for the last lakes that may have existed on Mars in the past. We knew Mars had water, and so what was the last swim of an organism in a Martian lake, and what did it look like? And how do we find evidence for it? So we work in these lakes as those analogs. That's one of the things we look at. And so this vehicle is looking at these lakes.
So you have a robot that
we have an autonomous underwater vehicle, an AUV, that is swimming around in a dry valley lake, West Lobe Bonnie. And the idea is to map out three-dimensionally the chemistry there, but the types of things that live there, the type of signature of the things that live there, and build this three-dimensional picture of the lake. And so it's one is as this Martian analog. The other is for ice-covered oceans on Europa, for instance, is how do we do autonomous 3D science when we can't be there to check it, right? So we're testing this vehicle and what the power budgets are, what kind of problems crop up when you try and do this in a cold environment, and so on. So the other is sort of an analog for doing an autonomous mission to an ice-covered ocean on Europa. And that's why NASA is interested. And these questions are important to everyone because we're trying to learn about how we got started, how life got started, and we're trying to figure out what are the signatures of early life, what are the behaviors of early life, and so on. And we're doing that in these places on Earth that are very, life is very tenuous there. It's just holding on by a thread. And so what are the strategies and what are the lessons we can learn from that?
Okay. I'm going to adjust this. I can move it back a little.